of starting machine is the DOL, and the DOL in full basically means direct online. So this is a method of starting whereby the motor starts directly on full load and full supply, or the full supply current. So in this method of starting, we have the following components. We have one contactor, oftenly called the main. We have only one. We have an overload relay. We have the actual load, which is a 3-phase IM, an induction machine, and we have the indicators. And basically these indicators, we have two. So we have the red to show power is available while the machine is not running, while machine is off. So when you stand on, there is a green indicator, show running. Then we have the amber. This one is designed specifically to show a trip. So this one will only, so there are two ways a machine will be off. Either it's turned off by pressing the off button, or it's off because it has tripped. So when it's off because somebody has pressed the off button, then it should be showing red in the LEDs. While if it's a trip, just either because of an overload or because of other reasons, then we're going to show this one by an amber, so that by a glimpse, when you look at the panel, you can tell whether the motor tripped or somebody switched it off, and the two are going to be separated. So let's look at the logic that is required. So we always have a line, and this one we call it the control phase. Then we have this control phase at the overload relay. I'm going to attach a picture of the same. We have a pin called 9596, which this pin is always a normally it's a normally closed pin. So this pin is normally closed. So this pin 9596 is a pin found on the overload relay, and this pin trips only when it only becomes open when there is an overload, or rather there is a short circuit of anything. Then so much current is drawn, then this pin, which is normally closed, will open, therefore tripping the motor. So, and the logic of the indicator to show tripping is going to be associated with these pins that are found and that are located in the overload, as are going to be shown in the picture displayed. So from here we go to the stop button, which is always indicated as that, which is also normally closed. Then we have the start button, which is normally open. So normally they call this one pin 1, 2, then this is pin 3, 4. Then from here we go to the coil of the main contactor. You connect that to A1, then the A2 here is connected to the ground. So with this arrangement here, you realize that when we press this button, current will flow through that line to this normally closed, so current will still flow to that place, continue. Then when you press this button, we complete this path, and the coil will be energized, hence the contact will be closed, the contacts of the contactor. However, you notice that this is a push button, is a PB. So immediately we release the push button here, as I'm going to attach an image as well. This button is going to open again to return to its normally state. So we need to create a mechanism to hold this in so that the coil will always have power until somebody has pressed the normally closed to open the circuit. So what are we going to build in that response? So there is a circuit that is called a holding circuit, and this circuit is built in parallel with the start button with the pins, the normally open pins of the contactor, like that. So these two pins of the contactor 13 and 14 are connected in parallel with the start button. Therefore, whenever you have pressed the button here and this path becomes continuous, so the contacts are closed. Once the contacts are closed, including the 1314 is closed, you realize that once we release this, there will be an alternative path to complete current to the coil, and so long as the coil is supplied, the motor will remain on until somebody has pressed the normally closed button here to disconnect or to interrupt that path that is created. And that is the logic of the direct online control circuit.